Now that we know about base 2, we can look at how computers talk. Base 2 can be used as a binary code. Binary means there can only be two states. Things that have only two values can use base 2 numbers to represent those two values. And we know that any base 10 number can be converted to a base 2 number. Remember, our original question was, how do your keyboard, computer, and screen communicate so that when you hit an A, the computer knows that it is an A and the screen displays an A? What if you put a CD or a USB drive in? How does the computer read what is on it? They have to speak the same language or they wouldn't understand each other, but they are all very different. They use different things to stand for 0 and 1, but they can all speak in base 2 and understand each other. All of these systems use the same binary alphabet, but they all use it for different things. For instance, on your screen, each pixel interprets a 1 or a 0 as whether it should be on or off. With a disk drive, each sector on the disk is actually a magnet that's either oriented north or south. Your keyboard speaks with electricity. It's either sending a signal through the wire or it isn't. And your CD works very similarly with disk drives, except there's either, in each location on the disk, there's either a hole or there isn't a hole. Each of these different systems has two states, and you can think of these two states as being either 0 or 1. This allows all of the different systems to talk to one another. ASCII, or the American Standard Code for Information Interchange, is a code for writing letters in base 2. The keyboard sends an ASCII code message to the computer telling what letter was just typed. This code will be literally 8 zeros or ones. So there's 8 place values. Here is a look at an ASCII table for the alphabet. Capital A is a 65 in base 10. In base 2, that is a 1 in the 64's place and a 1 in the 1's place. It's very easy to read. So when an A is hit on the keyboard, there are essentially physical place values that send an on where the 1's are and off where the 0's are. When a computer wants to tell the screen what to display, it does so using a bitmap. A bitmap is a binary code where each place value stands for a different pixel, which are the individual light bulbs that make up your computer's screen. Now, color monitors are a little more complicated. With color monitors, each pixel actually has 4 little light bulbs in it, one of which is white, one is red, one is blue, and one is yellow. And then the different binary codes that get sent control each subpixel to display different colors. But as you can see, the more pixels you have, the smoother the image will be. With a bitmap, each pixel is either on or off, transmitting black or white. The more pixels there are in a given image, the smoother the shape will be. But also the more binary codes you'll need to transmit that image. Let's pretend this R is displayed by pixels on a computer screen that has really bad resolution. This resolution is 5 by 6. Do you know your own computer's resolution? First, we convert the orange boxes to 1s, and now we're going to convert the aqua boxes to 0. So every row on the screen is a series of 0s and 1s. Try this. There are 5 pixels in a row. The bitmap starts at the bottom and reads left to right. This code simply draws the letter. What letter would this be? Attract is 1 and repel is 0. This is why you don't want to have magnets near your hard drives or any part of your computer really. So there you have it. That's how computers talk to one another, using binary codes in base 2.